In order to do histology, we have to be able to image things that are very, very small. And to do that, we're going to magnify them. So in order to understand magnification, I've created this little video that's going to explain it in a very bare bones kind of manner. So keep in mind, this isn't a physics class. We're not getting into the physics of optics, but we're just trying to get a handle on how lenses allow us to look at things that are really, 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 really small. So if we look at this picture here, we can see that we've got this arrow right here. And light rays from the bottom of the arrow are along the central axis of our vision, so they're going to pass straight through. And light waves from the top of the arrow are going to be coming into the eye at an angle such that they're going to cross over, and an image is going to be formed on our retina of the arrow. So we're going to view this arrow, right? Our eye is just going to kind of follow these lines back to the source, and we're going to see the arrow at life size. Now, if we put a lens in between our object and our eye, we're going to see some changes take place because that lens is going to bend the light waves. And in so doing, our eyes are no longer going to follow a path back to the actual object. Instead, our eyes are going to follow a virtual pathway and form a virtual image of the object. So what gets projected onto our retina appears to be much larger than it actually is. This demonstration was done with a single lens system. Modern compound microscopes are actually going to use multiple lenses, and each one's going to bend the light a little bit more, allowing us to achieve even greater magnifications. However, we can't magnify to infinity, and we'll learn more about that in the next video.